Hi everybody. So this is just going to go through a parallel circuit. We're going to use polar form to come up with an impedance and an angle for us. So I'm going to know my circuit impedance and my circuit angle based on these three properties. So with my calculator, we just need to make sure that when we are in our proper settings, so we're using complex mode. If you're using a graphing calculator, you're going to have to make sure you're calculating in polar method. Or if you calculate it, there's a lot of graphing calculators. If you leave it in rectangle, you can just quickly convert it over to polar method for your final answer. But this is what it's going to address is the polar method. So looking at the magnitude and the angle. So when we calculate impedance total, that is, we are using the formula of 1 over impedance total is equal to each of my factors. So 1 over, now when we're doing polar method, we want to make sure we keep all of those, the magnitude and the direction, intact. So I'm going to have R, which is at 0 degrees, so that's R1, plus R2, which is at 0 degrees. And this is the important one to remember, that it's plus 1 over x L, which is at 90 degrees. So when I'm punching this into my calculator, I like to do this in one step, and I like to actually write it out in how I am going to place it into my calculator. So for me, this is just the method that I've developed for myself to reduce errors that I don't miss and skip something. So I'll place each of these in brackets, and then rather than doing it as an extra step at the end, I do the 1 over right from the get-go. So the important thing to do with that is to add a bracket so your calculator knows that you're doing that definitively, all underneath, all on the denominator. So when we go to place this in our calculator, I have 1 divided by, and this is where we start with our brackets. So with the outside, and then I need another one for my first function, which is 5. And you'll notice this DMS on this calculator, that stands for degrees, minutes, and seconds. If you'll notice right below it, it has our little angle symbol. So that's angle or vector, depending on really what type of math or what type of calculation and convention that they're using for it. So we're 1, I can't remember the inverse. So I have to do 1 over 5 at 0 degrees. So that's our first function right there. Plus, bracket, 1 over 8 at 0 degrees, plus 1 over 6 ohms at 90 degrees. Close the bracket, and then I'm going to finish that statement off with my last to say it's all under the denominator. I hit equals, and I end up with 2.73. I'm going to change colors there. I'm going to leave it in black. 2.73 8 ohms, we'll call it. Now, the beautiful thing about doing this is I have my angle as well. So what I'm trying to cycle between is right now in the top left, you'll notice we are in the R theta mode. That's radius and theta. So if I go right beside it, in the EXP button, you'll notice the 2 arrows that look like this. What this does, it cycles between the 2 functions. So between the radius and theta, the angle. So if I hit second function, which allows me to use all of the extra components, and hit EXP, you'll notice I get my angle, and it shows you the little angle symbol. So I could actually say my impedance is 22.738 at an angle of 27.1, let's just round it to 15 degrees. Nice and simple. this just takes us right through how to add impedance in a parallel circuit. It's quick, it's one step, and it's using the tool, using the calculator as its intended function. So I hope this has helped. If you need any refreshers or you need any extra assistance, please feel free to reach out. Let me know, and I'd be glad to help guide you through. I look forward to seeing you in the next one. Thanks, guys.